Okay, so for this problem we are rolling a die repeatedly until a 6 appears. What is the probability that more than 4 rolls are required to make this happen? So if we let x is the roll number of the first 6 that appears, then this is a geometric distribution. We're waiting until the first success, and that is the canonical example of using a geometric distribution. Okay, now there's a couple ways that this can be done. First off, the probability that x is greater than 4, so more than 6 rolls. So the probability for a geometric distribution has the form p times q to the n minus 1, and I'll just add these up for 5 or more. For my example, p is 1/6 and my q is 5/6 to the n minus 1. And this is now an infinite geometric series. And the formula for an infinite geometric series, if you forgot it, let me just put it up here so we can remind ourselves what it is a plus ar squared, and so on, would be equal to a over 1 minus r. For this example, the first term of the geometric series would be 1/6 times 5/6 to the 5 minus 1, or 1/6 times 5/6 to the 4th. That's the first term. If n equals 5, that's the first term of this series. That would be the first term. Okay, now the common ratio is 5/6. When you go from one term to the next, you're multiplying by an extra 5/6. So 1 minus 5/6. And so we get 1/6 divided by 1/6, and those cancel, so we get 5/6 to the 4th. And so that's the answer. There's a second way to do this problem that is perhaps simpler, and it's to recognize this. The probability that x is greater than 4 is the same thing as the probability that none of the first 4 rolls is a 6. The first roll is something other than a 6, the second roll is something other than a 6, the third roll is something other than a 6, and then the fourth roll is something other than a 6. And so that's each of those happens with probability 5/6, and I need to happen 4 times. And so of course I get the exact same answer, just thinking about it a different way. For this problem, of course, you don't have to solve it 2 different ways, but I just wanted to illustrate that there are 2 different ways of doing this that lead to the same answer.